Hi all, today we will learn an important concept in general pharmacology, that is volume of distribution. From the name itself, it is clear that volume of distribution is volume in which the administered drug is distributed. For example, 500 milligram of drug is administered. Okay, so volume of distribution means that the volume in which this 500 milligram of drug is distributed, that is the volume of distribution. In order to understand better, we will see this with an example. Fine. So here the administered dose is 1000 milligram. We have to find out the volume in which the 1000 milligram is distributed. That is the volume of distribution. And it is known that 50 microgram per 50 milligram per liter is the plasma concentration, which means that 50 uh, 50 milligram is present in 1 liter of the plasma. So volume of distribution is equal to 1000 by 50 is equals 20 liters. So 1000 is literally what the dose of drug administered, okay, and 50 is literally what the plasma concentration. So if we want to derive a mathematical formula to calculate volume of distribution, so volume of distribution is equal to dose administered by plasma concentration, and it can be defined as the volume in which the drug is evenly distributed. The assumption that the concentration of the drug in the plasma and as well as in the different tissues are equal. So basically, the volume of distribution is the volume in which the administered drug is evenly distributed. So clinically, volume of distribution is used to estimate the extent of distribution. So if we tell that volume of distribution is 1300 liters, so this drug has taken 1300 liters of volume to distribute. That means it is widely distributed to different organs and tissues, right? So, and if we say that the volume of distribution is 500 liters, it means that the drug is confined only to a small volume that is mainly confined to the blood vessel itself. So the volume of distribution is very less. Now, coming to the factors governing the volume of distribution. Factors governing volume of distribution is same as factors affecting the drug distribution. So we know that in order the drug to get distributed, it has to pass this barrier, this blood barrier in the blood vessel. So this depends upon two factors, that is lipid solubility. Only lipid soluble drugs can pass through this barrier, and second is only unionized drug can cause this barrier. So it depends upon pKa, that is ionization constant. Okay. Then lipid solubility. Coming to the third factor, we know that plasma protein binding makes the drug very large molecule. So very large molecule cannot pass through this membrane. So we are very high plasma protein drugs are mainly confined in the blood vessel. So degree of plasma protein binding. Highly plasma protein drugs are more confined to the blood vessel, so their volume of distribution is less. Then now coming to diseases like CHF, uremia and cirrhosis, and CHF congestive heart failure. And if you notice in these conditions, the blood circulation in our body is decreased. So the distribution is also decreased and the volume of distribution is decreased. Now coming to the affinity to different tissue. So our body has different organs and tissue, and inside these tissue there are some protein, and some drugs are attracted to this protein and making the volume of distribution more. So the affinity to different tissue affects the drug distribution. That is, some organs have some proteins which attract these drugs. So the fourth factor is affinity to proteins in tissues. Okay, and fifth factor is fat. The presence of adipose tissue increases volume of distribution because more drugs will be moving to the fat tissue. And finally, as discussed, the diseases like congestive heart failure, uremia, cirrhosis, the blood flow will be decreased, and thus the volume of distribution is decreased. So in this class we have learned about the definition of volume of distribution, that is the volume in which the administered drug is distributed. Okay, and the formula for calculating volume of distribution is dose divided by the plasma concentration. And second thing we have learned is that factors affecting volume of distribution, and first is lipid solubility, second factor is ionization, third factor is plasma protein binding, fourth factor is affinity to proteins in tissues, fifth factor is conditions like CHF, uremia, where the circulation is decreased, so volume of distribution is also decreased. So I hope this session is clear for you. So please do subscribe our Instagram channel and YouTube channel, and you can reach out to me if you have any further doubt. Thank you.